hopefully everything's fine and dandy. So hi, everyone. I'm sideways right now. I'm sitting this way so that way I can get the whole paper in the screen, and I may have to go back later and change it. But regardless, hello. This is weird. I feel like I should just say that right off the bat. Weird times we're living in, crazy things. But hey, this is what we got to do to reach out, connect with one another. Let me know, honestly, if you think this helps, if you think this is worth the time and effort, or if it's just not working out. Maybe we can try Zoom or something like that in the future. But for now, we're going to go through with this. So kick back, grab your beverage of choice, and let's have some fun. So when you go to sit down with the Regents exam, the very first thing you're going to do is you're going to reach the very back and you're going to pull out the last 3 pages. Now, I know you guys didn't really have this physically. You had it digitally, but still, point still remains. The back pages are your graph paper and your reference sheet. So you're going to pluck them, file them off to the side. And once you've done that, you're ready to get started. So we're just going to go through. And like I said, I'm just going to go through each of these problems. The reason I wanted to do it on YouTube is so that way you can watch it later at your own pace rather than something where it's just a single live stream, then it's done. So question number 1. On the set of axes below, triangle ABC is graphed. Triangles A prime, B prime, C prime, and A double prime, B double prime, C double prime, which are the images of the original, are graphed after a sequence of rigid motions. Identify which sequence of rigid motions would map ABC onto the prime version and then the prime version onto the double primed. So first off, let's deal with that first one, from the original to the single primes. If you can't look at that and immediately tell it's a reflection, one thing you can remember is that there's only one kind of rigid motion that's going to change orientation, meaning this goes A, B, C clockwise, but then when I get down here, it reverses its order of the vertices. The only thing that's going to switch that up is a reflection. So immediately, I'm going to cross off 1 and 2 because I know the first thing has to be a reflection. And then to get from here to here, yeah, that's a rotation. So 4 is my answer for the first one. Popping that off to the side. Next one. Table below shows the population and land area of 4 counties in New York State at the turn of the century. They want to know which one has the greatest population density. For that, all we need to know is which one has the most amount of people per square mile. So this is just an easy calculator question. For each of them, we're just going to go through. Let's do Broome. Let's take the number of people, which is 200,536. Divide that by the number of miles, 706.82. That gives me 284 people per square mile. I'm just going to do that for all of them. Dutchess County, 280,150 people in an area of 801.59. And that gives me 349. So immediately, hey, that's bigger. It's not Broome. Go down to Niagara. Now, if you see with Niagara, it's got less people in less space. 219,846 divided by 522.95, giving me 420 people per square mile. Go ahead and laugh if you need to. Now over here, I see it's the least amount of people almost, and it's the most amount of miles. It's definitely not going to be Saratoga. You can plug that in and see it for yourself, but the answer here is Niagara. It has the highest population density of these counties. So if a rectangle is continuously rotated around one of its sides, what is the 3-dimensional figure formed? Y'all, when you get these questions, just pick up your paper and do it. If it's going to be rotated around one of its sides, that means I've got my paper. Here's the side I'll rotate it around. And as I spin it, I see what shape I have formed. Or you could sit there and say, I've got a rectangle. Here's the side I'm rotating it around. And as I rotate that fully around, the shape I get is a cylinder. That answer doesn't make any sense. If I'm going to be rotating it, shouldn't there be a circle involved in some way? Why would it be a rectangular prism? Can't be a sphere, can't be a cone either. It's got to be a cylinder. All right, number 4. Which transformation is going to carry the parallelogram onto itself? So the answers we've got here, the first 2 are reflections. The other ones are rotations. Now, first of all, remember, any parallelogram, you can't really fold it in half unless it's a rhombus. You can't fold it along one of these diagonals. But just to highlight that, the first one is a reflection over the line y equals x. Remember, the line y equals x is the line that goes through the origin with a slope of 1. I'm just going to rough that in. It'd be like folding the whole thing over that line. Now, if I look, remember, the line you're reflecting over tells you everything you need to know about the way one point becomes another. In this case, point M, well, that's going to go to a new point where the y becomes the old x. So in other words, its new y value is -2. Its x value is 3. Is this point the same coordinates, 3, -2? No. So it's not that one. Same deal if you try with the other line to reflect over. Y equals -x is a line that goes through the origin with a slope of -1. If I do the same thing, let me take, okay, point A. Again, the line you're reflecting over tells you what happens. The new y is just the negative of the old x. So my new y value is -4. My x value, if I am going from here to here, my x value is staying, oh, sorry, I'm going over the red line. Going from here to here, my x value is becoming negative as well. If I look, those are not the same coordinates. A rotation of 90, it should be easy to see if you rotated this thing 90 degrees, it's going to be facing the wrong way. It's got to be a rotation of 180 degrees, which means just take it, flip it upside down. It's going to be the same thing. Now, after a dilation centered at the origin, the image of CD is C prime D prime. They give us the coordinates of the endpoints of the original and the image, and then they want us to get the scale factor. Remember, scale factor is just image over pre-image. It is really weird to write up sideways, I'll tell you what. So, if I want the image over the pre-image, first thing I'm going to do is I'm going to look, okay, let's take my original, C and D. My original x values are 4 apart, and my original y values are also 4 apart. That's my pre-image. Now, if I look between my image points here, the x values have gotten bigger. They're 6 apart now. So immediately, if I see that they're bigger, I'm going to get rid of any scale factor that's less than 1. And these ones are also 6 apart. So it's 6 over 4, and I can reduce that to 3 over 2. And that is my scale factor. First 5 questions, going to hold there. If anyone wants to ask something in the chat, go ahead. As I sip my delicious seltzer. Alrighty, I think we're going to move on to number 6. This is a straight up volume question for number 6. A tent is in the shape of a right pyramid. That means it's a pyramid where it just goes straight up. It's not slanted and wonky off to the side with a square floor. So I'm going to go ahead and I'm going to draw that pyramid with the square floor that goes up like that. The square floor has side lengths of 8 feet. So that side's 8, that side's 8. The height of the tent at its center is 6 feet. That means like this vertical height is 6 feet. We want to know what the volume is. Well, we know that volume of a pyramid is just 1/3 of the area of the base times the height. Well, the area of this base is just 8 times 8. That's 64. So volume is 1/3 times 64 times 6. So all I have to do is 1/3 times 64 times 6. And you can see right ahead that 1/3 of 6, oops. 1/3 of 6 is just going to be 2. So really all we're doing is we're just multiplying 64 by 2 to get 128. In our units, cubic feet. All of our originals were in feet, so we know we're A-okay there. Next one. This line is transformed by dilation We want to know the equation that could represent its image. Immediately, you should take a look at all of your equations here. They're all in slope-intercept form. They're all in y equals mx plus b. So I'm going to take this equation that they gave me to start with, and I'm going to at least make sure that's in slope-intercept form. So I've got negative 3x plus 4y equals 8. And then I'm going to go ahead and add 3x to both sides to get 4y is equal to 3x plus 8. Divide both sides by 4. The whole side by 4. My original line is y equals 3/4 x plus 2. Now that I've got that, I'm going to go ahead and I'm going to look and notice that they want to know what's going to happen if I dilate this line. Remember, if you dilate a line or line segment, dilations always carry lines and line segments to parallel ones. So my new image has to have the same slope as my original. So anything that doesn't have a positive 3/4 x, I'm just going to cross off, leaving me with the only option that remains, number 2. Down to number 8. Lines AC and BD are intersecting at E. Which information is always sufficient to prove that these two triangles are congruent? So remember those triangle congruence theorems. First of all, these are lines that are intersecting, means immediately I have a pair of vertical angles here. I know that for a fact. I'm going to go through each of these. First of all, that AB would be parallel to CD. Well, if those lines were parallel, I would be able to say, okay, then those are congruent and those are congruent because they're alternate interiors. But you can't prove that two triangles are congruent just based on only angles. Can't use that one. Next one says that AB and CD are congruent. That's a pair of sides. And then BE is congruent to DE. ASS, not a congruence theorem. That E is the midpoint of AC. Well, that would give us that's equal to that. But that's just an angle and a side. That's not enough. BD and AC are bisecting each other. That means this one's broken in half and that one's broken in half. That's side angle side. That is enough to show that those two triangles are congruent. Number 9. When you get a question like this, Geometry Regents will always have at least one. Sometimes they'll have 2 of them. When you get a question like this, jump for joy. You can walk into the Regents exam knowing absolutely nothing about geometry. There is no excuse for getting this question wrong. You've got a calculator right there. The expression sine of 57, first let me make sure I'm in degree mode, which I am. Sine of 57 is equal to that. It is equal to which of the following? Well, let me try tangent of 33. Nope. Let me try cosine of 33. Hey, wouldn't you know it? It's equal. Great, it's that one. The other thing is to remember the rule that's actually happening here. If you have 2 angles, sine and cosine, or if you have 2 angles, A and B, if you take sine of one and cosine of the other, this will only happen if A and B are complementary. And if you see here, 33 plus 57 will equal 90 degrees. So always remember that, especially with a question like this. There's no reason to get that wrong. Just plug it in your calculator and check it out. 10. What is the volume of a, now here they are double tricking you, hemisphere, half a sphere, which has a diameter of 12.6 centimeters. They're tricking you in 2 places. First of all, the volume formula we have for a sphere is exactly that. For a sphere. This is a hemisphere, half of a sphere. So what we're going to have to do is take half of this. Remember what you can always do? Take 4/3. If you cut that in half, it'll be 2/3 pi r cubed. Now, the other way they're tricking you is diameter. This is a radius. So if the diameter is 12.6 centimeters, the radius is 6.3 centimeters. So I'm going to plug all that in. My volume is equal to 2/3 times pi times 6.3 cubed. Ollie, I'm not sure why you're in this chat, but hi, welcome to geometry. 2/3 times pi. Now they are saying to the nearest tenth, so it's okay. We want to actually multiply by pi here. Times pi times 6.3 to the power of 3. And I look for 523.7. I just want to point out where all these other answers are coming from. Let's say I tried doing this, but instead, can you guys even see this? Is this showing up on the camera? Oh, not very well, huh? I guess I got to do that. If I do the same exact formula, but if I forgot to take half of it, if I did 4/3, that's that option there. It's a trick. So be very, very careful about these. And I am willing to bet that these are things that happen if you forget to cut the radius in half or if you square it instead of cube it. So again, they try being tricky. Don't let them trick you. I'm going to hold there. That's another 5 questions. Going to see if anyone's got any questions down there. And by anyone, I mean Sid or Ollie or anyone else who's in the chat that I don't know. Hope you guys have been able to at least step outside, get some sunlight. Remember that vitamin D is super, super important. It's a thing that actually keeps us sane and keeps us healthy and happy. So make sure you're getting some sunlight, even if it's just stepping onto your porch or throwing a ball in your front yard, whatever it may be. Make sure you're at least staying active, staying healthy out there. Alrighty. I'm going to hop down to number 11. In the diagram below of triangle ABC, D is a point on BA, E is a point on BC. Okay, so exactly what it looks like. BD is 5. DA is 12. I'm going to immediately fill in and say, all right, well, if that's 5, that's 7. BE is 7. I want to know the length of BC, the whole thing, so that these two lines are parallel. What this is the side splitter theorem. Remember, these two lines can only be parallel if it is splitting these two sides in proportion with one another. So in this one, yeah, we wound up actually not needing this 7 part, but it's okay to write it in there. So I'm going to find out what is the proportion of this top part to the whole. It's 5 over 12. Well, what is this top part? And the thing I'm trying to find is BC, which is the whole. So that's what I'm going to label as my X. And all I have to do is a bit of cross multiplication. 5x is going to equal 7 times 12. Oh, that's a 4. I got to angle it a bit, I guess, for you guys. 84. So I'm going to just divide that by 5. And x is equal to 16.8. That's the side it must be. A quadrilateral must be a parallelogram if. Okay, so this is one where you can remember it by the rules of parallelograms, or you can go ahead and try finding some counterexamples. We know it's a quadrilateral. Everything we have has 4 sides. If one pair of sides is parallel and one pair of angles is congruent, well, I could draw this. This is a quadrilateral with one pair of parallel sides, and it's got a pair of angles that are congruent up here. That's not a parallelogram. One pair of sides is congruent, and one pair of angles is congruent. Again, here's my counterexample. 2 sides are congruent, 2 angles are congruent. Not that one. One pair of sides is both parallel and congruent. We'll come back to that in a sec. The diagonals are congruent. Well, remember that something that has its diagonals congruent would be a rectangle. Over here, one pair of sides is both parallel and congruent. Is there a way we can make that happen without it being a parallelogram? No, because any way you force them in, it's going to force the others to be the same. Whereas if the diagonals are congruent, can that happen with something that's not a parallelogram? Yeah. Same as over here, my isosceles trapezoid can do that as well. It's got to be option number 3. Remember, a parallelogram is a quadrilateral with both sides parallel and congruent. If you just know one of them is and it's a quadrilateral, that's enough. This was one you did not know how to do. I told you could skip it. We haven't gotten to circles yet, although something tells me in the next few weeks we may have to learn a little bit about circles. Oh, I see Sid's asking a question about number 11. 11 is asking for BC. So wouldn't you have to add 7 to it? No, because the way I set up my proportion, over here I said the top part to the whole, which was 12. So over here, I did the top part. My X is my whole. So I don't have to. If you set it up and you did 5 over 7 is equal to 7 over X, and you call this part your X, then you would have to add it in the end. But I can show that right now. That'd be 5x equals 49. So I'll do 49 divided by 5. That means this X is 9.8. If I add 7 to it, again, I get 16.8. So be careful about that. It's always, I like saying part over the whole. Is a good way to keep it straight. So again, 13 was one we didn't get to. I've got a feeling that as this whole pandemic kind of continues, we may have to learn this online and digitally with one another in a Zoom class or something fun like that. Hopefully we don't get to that. Instead, I'm going to look at, what word are they trying to spell here? Jerome, whatever. So I'll just do this really quickly, show you the way it would be done. EM is 8. RM is 15. The lengths of JM and TM could be. So what this is a circle. These guys are considered to be chords. That's the word for them. The rule here is that when you've got two chords that intersect, the products of their parts have to be equal. So if I do 15 times 8, it's 120. I need two numbers that are going to also multiply to 120. I'm going to skip this because, again, we haven't gotten to it before, but that's the way you would go about it. Who just joined? Kaylin. Hi, Kaylin. How's it going? So triangles Joe and Sam are drawn. Are they? Well, now they are. J-O-E. And I'm going to make sure I put my letters in the same exact spots. S, A, and M. They're drawn such that E is equal to M and EJ is equal to MS. Which mapping would not lead to those two triangles being congruent? J mapping onto S. Well, that would be angle, side, angle. That could show that they're congruent. Number 2, O maps onto A. That would be angle, angle, side. Remember, if you ever have two angles and a side in a triangle, that's congruence because it's either angle, side, angle, or angle, angle, side. So you want to look at the sides for these questions. EO maps onto MA. Well, that would give me side, angle, side. Over here, JO maps onto SA. That would be ASS. They ask a lot of these questions. Do not be an ass. You know that rule. We've done that rule 1,000 times. And hopping down into number 15. In triangle ABC shown below, angle ACB is a right angle, E is a point on AC, and ED is drawn perpendicular to that hypotenuse AB. If AB is equal to 9, BC is equal to 6, and DE equals 4, what's the length of AE? That's what I want to know. I'm going to take this little triangle in here and I'm going to flip it and pull it out. I'm going to draw it in the same orientation as my big one. If I look at my little one here, the short leg was 4. And what I'm trying to find out is the hypotenuse. So This is a rule we learned. It goes by many names. The simplest way, which tells you exactly what it is the altitude on hypotenuse theorem. This is also the geometric mean theorem. In other words, we know that these two triangles here are similar. So they're going to be in the same ratio. So all I have to do is I'm going to set up a ratio between the small one and the big one. I'm going to say this leg over the big one's leg has to be equal to the little one's hypotenuse over the big one's hypotenuse. So 36 is equal to 6x, and x has got to equal 6. Just double check, make sure that makes sense. Hey, does it make sense that the hypotenuse is bigger than the leg? Yes, we're okay. And I'll do 16 as my fifth one to take a break. So, which equation will represent a line parallel to the line whose equation is this and passes through that point? Well, remember, to be parallel means you have the same slope. So I'm going to take this and I'm going to make sure I know what its slope is. The line's equation is negative 2x plus 3y, which is equal to negative 4. I'm going to get it into slope-intercept form so I can see the slope that way. Add 2x to both sides. Divide by 3. Here is the slope of my original line. All of these answers are in point slope form. So remember that slope can be found in front of the parentheses. Get rid of these. They're wrong. So it's got to be one of these. Now remember, point slope form tells us we have to subtract off the coordinates of each. In other words, I would plug it in. If I have a point with these coordinates, x1 comma y1, and a slope of m, if I have those two ideas, I would say y minus y1 is equal to my slope times x minus x1. So I want the answer that's got a -1 and a -3 in it. It's got to be option number 2. Those are my 5 questions. I'll take a quick little break. If any of you guys have any questions you want to put into the chat, anything you want me to go back to, if you joined in a little late, let me know. And I'll give you a second to do that now as I once again sip my glorious, wonderful seltzer. Yeah, let me know if this is looking totally wonky and sideways on your screen, or if it's looking okay. If you're sitting there going, hey, Lacella, I can't read a single thing you're writing, well, that's a problem too. Again, we're all doing a little bit of growing pains and figuring out how to do this our first time. So there's bound to be a few hurdles we need to jump through. And any questions in here? Are you going to do a Zoom call? I may do that if I feel the need arises. We're going to see. Again, as of right now, we don't have an answer for when we're getting back. My understanding is our original call of when we are ending this break was next Wednesday. But I mean, we're not going to be back in school next Wednesday. I'm fairly certain of that. So moving forward, it's a matter of I'm just waiting to hear, what the word is, what the directive is from administration, from the district. If the answer is they want us to continue to learn and continue instruction and going forward, preparing for end of year stuff, then we're going to need to figure out a way to deliver the instruction and to deliver classes from farther away. That may include me doing pre-recorded videos and uploading them. That might include a live Zoom feed. I don't really know what that answer is. So I am open to trying Zoom. I've never used it before. I'd never heard of it before this whole thing happened. But I'm willing to try it, and we'll see how it goes. And it might be a good idea just to do like little review sessions and things like that. So maybe we'll do Zoom. We'll see. Any other questions for 1 through 16 at this point? And remember, in theory, this should be viewable once it's over, and you could just pull it up on YouTube. Alrighty, let's take a look at number 17. Rhombus TIGE, which are intersecting at R. They do this a lot. They make fun little words, just like I do, only theirs don't have a common theme or something. They just choose random words. So really easy to skip this word. It's a rhombus. That's really important to know that this thing's a rhombus because it tells you that the diagonals are all perpendicular. And it also tells you all of the sides are congruent. You cannot do this problem without knowing that it's a rhombus. So be very certain you catch that word. They're intersecting an R. The perimeter is 68. Remember, perimeter is all the sides added up. So if I know that that's 68, the first thing I'm going to do is I'm going to take 68 and divide it by the 4 sides that I have. So that way I can find out that the length of each side is going to be 17. So I'm just going to label them all with a 17. TG, this whole thing, is 16. Again, knowing that it's a rhombus means it's a parallelogram, which means its diagonals bisect each other. They want the length of this whole diagonal, i.e. Now, I'm going to stop here and I'm going to make a guess. My guess is, okay, they want the whole diagonal. I can see I've got a right triangle because I know this is a rhombus, where I know this leg is 8, this leg is 17. If I find that leg, I can find the entire diagonal. The guess I'm saying is, if I would look at this, I would immediately guess that the answer is probably going to be 30, because chances are they're banking on you solving for this as 15 and not doubling it. Let's see if that's right. Right triangle means it satisfies the Pythagorean theorem. 8 squared plus x squared equals 17 squared. And by the way, I'm not doing this performatively or anything. I am going through this with you for the first time. So I truly am making a guess going, yeah, I bet that's what they're doing, the sneaky little jerks. And 17 squared, 289. So I'm going to do 289 minus 64 to get 225. And sure as sugar, square root of that is going to give me, oops, I added a plus and I shouldn't have. Square root of that gives me 15 as my x. But I remember that that's my x. That's half of the diagonal. Double it to get my 30. Sometimes their attempts to be tricky can give you the right answer. So, keep your eyes out for that. This is another one you did not know how to do because we haven't done circles yet. Again, just a little preview of what's to come. I've got a circle, so I'm going to go ahead and draw my circle. There we go. In circle O, I have 2 secants. A secant is a line that crosses through the circle twice. So I've got boom and boom. Those secants are A, B, P, and C, D, P. They're drawn to the external point P. I knew that because they both have the same letter in common. If arc AC, that's how that's read, arc AC, this has a measure of 72 degrees. BD has a measure of 34 degrees. What's the measure of angle P in here? The rule there is simply that this is going to be the difference between the two. You subtract them and get your answer. But again, we haven't gotten to those, so don't have to worry about doing them just yet. 19, directed line segments. This is a great problem to use some graph paper for. The coordinates of point C on the directed line segment from A to B will partition it such that AC to CB is 2:1. Again, think of what this is saying. I have a line, A to B. I have a point somewhere on it, C, such that I have to take 2 steps to get to C, but only 1 step to get to B. They want to know where C is in that case. Of course, the line isn't directly straight like this. It's on a slope. I'll show you how to do it graphically. I'm going to use red just so it shows up a little bit better. Oops, that is not a straight line, dummy. There's one. And bing, bang, boom, here's the other. So my points are -8, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's my point A. B is at 10, negative 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 2. And here's my line. First thing I'm going to ask is, what is the slope of this line? Well, I have to go down 1, 2, 3, 4, 5, 6. I'm going down 6. My rise. And my run, I have to go, okay, well, if that was 8, that was 10, it should be 18, which was a slope of negative 1 over 3. And is that right? Down 1 over 3, down 1 over 3, down 1. Yes, it is. So again, to do these, I like to draw in that little staircase, or at the very least, just draw in all my little points. Okay. So I need to make 2 steps from A, because it's AC is 2 to 1. If I take 2 steps, there's not 1 step left to B. So instead, I'm going to just keep going along. And if I see at this point here, it's breaking it up so that I have a section 1 and then 2 to there, and then just 1 section of 2 length. So in other words, they tried being a little tricky here. You just have to be careful. Graphing these out is the best ways to do them. I'm just going to read those coordinates. Looks like that is at 4, 0. And there's my answer. The equation of a circle, again, we haven't gotten to these yet. The way you would do this is a little thing called completing the square, which you saw a little bit of last year. Plus 8x, I leave a blank. Plus y squared minus 12y, I leave a blank, equals 144. I'm going to take half of this, which is 4, and I'm going to square it. I'm going to take half of that, which is negative 6, and I'm going to square it. I'm going to have to add that to both sides in order to keep this equation balanced. So then I'm going to do 144 plus 16 plus 36, 144 plus 16 plus 36. That side equals 196, which means my radius is 14. It's a little complicated, but you would go through it by completing the square. And then I could write this and say, okay, this is going to be x plus 4 squared plus y minus 6 squared is equal to 14 squared. This would be the equation of the circle. And then we would read from that the center is at negative 4, positive 6 with a radius of 14. You'll know how to do these just fine and dandy by the time we get to them, but you weren't expected to know it now, so don't worry about it. In parallelogram, PQRS. PQRS, I'm going to go ahead and I know this is a parallelogram, so I know these are congruent. I know these are parallel. Gives us lots of fun stuff. QP has been extended to point T and ST has been drawn. If ST is congruent to SP and angle R is 130 degrees, what is the angle of PST? This one up here. So this one's asking us to do a lot of jumps. But I know this thing's a parallelogram. If this is 130, the opposite angle has to be 130 degrees as well. And if that's 130 degrees, this thing that forms a linear pair with it has to be 50 degrees. Since these two are equal, this is an isosceles triangle. So the base angle theorem tells me that that's also 50 degrees. Sorry, I'm like writing totally sideways. So then that means these two angles add up to 100 degrees. So if I just take 180 degrees and I subtract off the 100, I get the 80 degree angle I have up there. All we got to do is just a little jumping around from here to here to here to here to there. And then you get it all. I'm not sure if there would be another way to do it other than sitting and saying, okay, then if this is 130, that means this angle here is 50 degrees. And then you could do a little bit of kung fu guesswork, but nah, I would avoid it. 22. I'm going to get through the end of the page here rather than stopping at 5 questions. A 12-foot ladder leans against a building and reaches a window. Anytime you hear a ladder leaning against, it's a trig problem. Just start drawing it. We've got a ladder that's leaning against the building. We always assume buildings are built correctly and they form a 90-degree angle. The ladder itself is 12 feet, and it leans against a building, and it reaches a window that is 10 feet above the ground. What is the measure of the angle that the ladder forms with the ground? This is the angle I want. I look and I see, okay, I've got a side that's opposite, and I've got the hypotenuse. So that means in my SOHCAHTOA rule, which some people said they like seeing it this way because it helps them visualize what has to happen. SOHCAHTOA, if I have opposite and hypotenuse, that's going to be sine. So I'm going to set up this trig problem. Sine of my angle is equal to my opposite side over my hypotenuse. So then my angle is equal to the inverse sine of 10 over 12. Again, you're always going to make sure when you grab your calculator for the first time that it's in degree mode. We're never going to do anything not in degree mode, so you should be locked in and ready to go there, but always check it. Inverse sine of 10 over 12 is going to give me 56.4, and they want to know it to the nearest degree. That's 56 degrees. Bing, bang, boom, done. In the diagram of this equilateral triangle, E and F are the midpoints of A and C. Ooh, lots of fun stuff they're giving me here. If EF is equal to 2x plus 8, and AB is 7x minus 2, what's the perimeter of this trapezoid, ABFE? So obviously, in order to do that, we're going to need to know what these parts are and then be able to do some other stuff with it. So first thing is, I see my top triangle is in a ratio with my bottom triangle because the sides are being split proportionally. I know that these two are split in the same proportion. That's in a 2-to-1. So in other words, if I take 2x plus 8, this has to be half of that one. So 2x plus 8, I'm going to say if I multiply it by 2, I get 7x minus 2. Also the mid-segment theorem because it's a mid-segment. So 4x plus 16 is equal to 7x minus 2. Subtract 4x from both sides, add 2 to both sides. 18 is equal to 3x. So my x is equal to 6. So immediately, if that is 6, this top part here, I'm going to redraw it. 2 times 6, which is 12, plus 8 gives me 20. I know that this should then be 40. Did I do that wrong? 2 times 6 is 12, plus 8 would give me 20. 7 times 6 minus 2. Oh, 42 minus 2, yeah, 40. Great. So now the perimeter has got to be at least 60, so I can cut 2 of them off. Now I just need to find the other 2 parts. A few ways to do that. Let's think. Well, since this is an equilateral triangle, I know that that angle is 60 degrees. So I know this one is 60 degrees. So I've got a triangle here where that's 60, that's 20. What I really want to know is this part and this part. You could use the law of sines here. Again, since this big thing is an equilateral triangle, that is also 60 degrees. So law of sines says I could say if I take this side 20 over sine of 60. Oh, yeah, I could also do that. I'm putting way too much effort into this, but you'll see what I just realized. 20 over 60 is equal to x over sine of its opposite side. Oh, the denominators are the same. X has to be the same. You could also realize that since my original triangle is equilateral and this thing's a mid-segment, this one's also equilateral. So if this is 20, and that's 20, that's 20, and since these are congruent, that's 20, and that's 20. 40, 60, 80, 100. Which information is not sufficient to prove that a parallelogram is a square? This is the second one of these we got on the same Regents exam. Which is not sufficient to prove that it is a square. So again, for these, I like doing counterexamples for each one. The diagonals are both congruent and perpendicular. That's a telltale way to know that something is a square. The diagonals are congruent and one pair of adjacent sides are congruent. Remember that the diagonals being congruent doesn't necessarily make that thing a square rectangle. You could have a trapezoid. An isosceles trapezoid will have congruent diagonals. But if you force these two adjacent sides to be congruent, it's going to force that thing to be a square. The diagonals are perpendicular and one pair of adjacent sides are congruent. And remember, perpendicular diagonals means the thing is a rhombus. So all the sides are equal. And then if you make the two adjacent ones equal, it's got to be a square. The diagonals are perpendicular and what? Diagonals are perpendicular and one pair of adjacent sides are perpendicular. Got it. Okay. No, in number 3, that would be the case of just having a rhombus, whereas this one here would make it a square. So it's got to be number 3. Sorry, I messed that up. I'll go through that again. The reason between the two, they're very, very similar in the end there, but the diagonals are perpendicular. So that part for both of them is telling you it's a rhombus. Is it a rhombus where the adjacent sides are congruent? That's any rhombus. Whereas down here, it's a rhombus with perpendicular sides. That makes it a square. And since they want something that's not sufficient, it's got to be option number 3. That kills our multiple choice right there. So I'm going to drink some seltzer. I'm going to take a quick break. You let me know if there's anything you want me to go back to in those multiple choice. There's a bit of a delay. You've probably heard the fan of my laptop running next to me. I've got that on, so I'm kind of watching it as I go. It seems like there's like a 10 or 15 second delay here. So if I take 15 seconds, it'll probably be 30 seconds. So I'll take a quick break, see if you guys have any questions. And it's such a shame that the weather's so nice today, you know? I took a quick little walk around the block and just got some fresh air, that vitamin D I was talking about. But man, it's such a shame. Can't really meet up with people and go on a hike or, play a game with someone. Really trying to keep that social distancing a thing, or physical distancing, I think is a term that they're trying to shift to a little bit. Again, the idea here just being if you are in contact with other people, you could be carrying this virus with you and not showing any symptoms and have no idea. And every time 2 people interact, that's a chance not only for that virus to find a new host and spread, but it's also a chance for it to have a new host to mutate in. And we don't want that either. So that's why it's so important we keep our distance between each other. Seems like that is that. We're ready to move on to the part 2s here. So part 2s, I've got triangle A prime, B prime, C prime, which is the image of ABC after a dilation with scale factor 1/2 centered at point A. So it is a dilation. What does it mean for something to dilate? It means it gets bigger or it gets smaller. And if that scale factor is 1/2, it's getting smaller. If it's getting smaller, can it be congruent? No. So we just have to explain that. First off, make sure you get one of your 2 points by saying no. Now explain your answer. Is it congruent? No, there's a variety of different things you want to say here. Be careful not to say the phrase, no, dilations produce similar figures. That is a correct statement. The reason you want to avoid it, though, is the fact that if 2 things are congruent, by definition, they are similar. So we need to specify and say we specifically know they are not congruent. I'm just going to say no. A dilation with scale factor 1/2 or K equal 2, or excuse me, not 2, 1/2. Yeah, you'll lose points for something like that because you're all of a sudden talking about something that's not related to the problem. So be really careful. A dilation with scale factor of 1/2 will cause the image to be half the size of ABC. So A prime, B prime, C prime would not be congruent to ABC. And yeah, you can drag all triangle symbols in there to be more specific. That's all you need to write in there. You could go ahead and draw a little diagram to explain what you mean and say, oh, well, that's my prime version, whereas that's my original, and then specify what you're saying. Give a little example, say if that's 5, the original was 10, something like that. But the key thing is, if you have the word explain, you need to have words. So anything you provide as an explanation has to have words in there in some way. So that's all I'm saying. A dilation with that scale factor, I want to explain to the grader that I know what that means. I know that means it makes the triangle smaller. Since it's smaller, it's not going to be congruent. There's our 2 points. Determine and state the area of triangle PQR whose vertices have those. The set of axes below is optional. You'd be a fool not to draw it. P has coordinates -2, -5, -1, 2, -1, 2, 3, 4, 5. That there gives me P. And then Q is at 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. R is at 6, 1. 1, 2, 3, 4, 5, 6, 1. Now, of course, this is geometry. They're not going to give you a triangle that lines up perfectly with the grid. But there are a few ways we can do this. The first way is the more direct way. I could sit there saying, hey, is this a right triangle? Well, between Q and R, my slope is -1, 2, 3, 4, 1, 2, 3. That has a slope of -4/3. And over here, my slope is 1, 2, 3, 4, 5, 6. 1, 2, 3, 8. So this one has a slope of +6/8, which is 3/4. That shows me these two lines are perpendicular. Since they're perpendicular, I can find the distance here and here, find their lengths, and plug it into a triangle formula. That's a lot. You can do that. It'll totally give you the right answer. But if you ask me, there's a lot of calculation there to mess up. Here's the cheaty way to do it. If I take this triangle, I could make a box that just barely touches all the vertices by going like this and get the vertical part. And this one. Can I find the volume, the area of that box? Certainly. Area of the big thing is just 1, 2, 3, 4, 5, 6, 7, 8 times its vertical part. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To give me that the box's overall area is 80 square units. How does that help me? Well, the triangle is within that box, so I know that its area, 1, has to be less than 80, but also I can get it by taking away all of these triangles. In other words, here's a bunch of negative space I want to get rid of. Now, the reason this is easier than the other method is these triangles are lined up with the grid. So they're super easy to find their area. You just have to make sure you remember that the area of a triangle is 1/2 the base times the height. So I'm going to go ahead and to show my work, I'm going to say, let's call this, triangle 1, triangle 2, and triangle 3. Let me go up to 1. Its area would be 1/2 of its base times its height. So that'd be 1/2 of 1, 2, 3 times 1, 2, 3, 4. Well, that would be 1/2 of 12, which would give me 6 square units. Region 2 over here, again, is a right triangle. Its area is 1/2 of its base, which we said was 8, times its height, which we said was 6. Let me just double check that. 1, 2, 3, 4, 5, 6. So that would be 1/2 of 48, or 24 square units. And for region 3 over here, its area is going to be 1/2 of its base, 1, 2, 3, 4, 5, times its height, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/2 of 50 gives me 25. So then if I take 80 and I subtract 6, I subtract 24, and I subtract 25, I should get the area of the white space in here. So let me just do 80 minus 6 minus 24 minus 25 to get that the area of the triangle I want is 25 square units. And if you've got the time, you may want to just do a quick double check and say, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and go ahead and go, yeah, it's about 25. Or you could sit and you could do a little rough estimate, but I've got my area right there. I'm happy with that. There's my 2 points. Pluck it and file it. Support wire. If you hear that word, it's probably a trig question. A support wire reaches from the top of a pole to a clamp on the ground. Here's my pole. And here's my support wire. The only downside to doing what I do, which is I immediately start drawing the diagram as soon as I read words related to it, is sometimes you draw it in a way that it's not to scale. Like it might say this angle should be like, 105 degrees. And I'm like, oops, but whatever. The pole is perpendicular to the level ground. I would hope so. And the clamp is 10 feet from the base of the pole. The support wire makes a 68-degree angle with the ground. Find the length of the support wire. Again, super easy trig problem. You get these, you should be able to go, oh, I know that. Boom, boom. Oh, they're giving me free points here. So if I look, here's my angle of reference. I have the adjacent side and I have the hypotenuse. So I'm going to use cosine of 68 degrees is equal to my adjacent side over my hypotenuse. So 10 is equal to x times cosine of 68, because remember, you have to multiply both sides by x. So then x is just equal to 10 over cosine of 68. So x is equal to 10 over cosine of 68. I'm going to put the whole thing in parentheses because I'm paranoid. And I get x is 26.694 something, something, something. They want find the length of the support wire to the nearest foot. That would mean it would be 27 feet. Does my answer make sense? Well, the hypotenuse should definitely be longer than any other leg, which it is in this case. Just be really careful you're rounding correctly and you're paying attention when they ask you to round it, because again, that's somewhere where this is only a 2-point question. If you left your answer unrounded, you're only getting half the credit. So just make sure you don't make stupid little mistakes. You always want to go back and double check yourself. I'm saying make sure you don't make stupid mistakes. You guys are probably going to go, oh, you messed up here and here and here and here. It happens. And if that's the case, then awesome, we're learning. Again, this is one I didn't really know how to do, but we've got a circle here with an arc that is 72 degrees. They want the area here in terms of pi. Again, you didn't know how to do this, so I'm just going to walk through really quickly. If this thing is 72 degrees, if I take my 360 degrees of a circle and divide it by 72, That's 1/5 of the circle. So if I found the area of the full circle, which is always pi r squared, that means the area of my full thing is 100 pi because my radius is 10. 1/5 of that would give me that the area of the sector is 20 pi. It's really simple, but that's just that. You didn't need to know how to do it, so it's okay. Describe a series of rigid motions that would map that onto that. I'm telling you they will give you this question, and I'm telling you, just remember turd or turd. If you do things in that order, it'll always work, but this is the one I usually tell you to do. So first things first, ABC is congruent to STU, so we know we don't have an impossible task here. Now, if I look, B maps onto T, so the first thing I'm going to say is translate my full triangle ABC, and I want to line up B with T because I see that's a point. I'm definitely not going to mess that up. If I try to make mapping A, B, but those I know will be right. I just have to move it 1, 2, 3, 4, 5, 6 down, 1, 2 to the right. So translate it 2 units right and 6 down. That's my first rigid motion. Gives me, okay, B is here. A is 1, 2, 1, 2, 3, 1, 2. That would be where my A prime would be. And then C prime would be here. And then if I want these things to line up, all I have to do is just then rotate 90 degrees counterclockwise. Turd, translate, then rotate. Sometimes you may have to reflect it. Sometimes you may have to dilate it. But if you do things in that order, or if you just keep that in mind, it'll help you explain what it is you have to do. Pluck it and file it. It's all good. Here's another question, which is altitude on hypotenuse. I see a right triangle, which is the overall one. Then they drew an altitude to the opposite side. In right triangle, PRT, angle P is the 90-degree angle. Altitude PQ is drawn to hypotenuse RT, and RT is 17, PR is 15. Determine and state to the nearest length RQ. Okay, so that's a little bit annoying, but it's okay. You got this. The reason I say it's annoying is because if I look at my overall triangle, I know the long leg and I know the hypotenuse. Oh no, it's not as annoying as I thought it was. And in the small triangle, I need to know its long leg, but I know its hypotenuse, so I can just set up an easy proportion here. I can draw both of these in the same orientation. P to T to R, P, T, R. And I know PR is 15. Oh, I just labeled the wrong side. PR is 15. RT is 17. And then in my medium-sized triangle, I need thicker lead. In my medium-sized triangle, which has right angle Q, across to P, and up to R. Wait. PR is, yeah, okay. I've got a hypotenuse that is 15, and I want to know X. Now it's really easy to see. All I have to do here is set up a proportion. And to set up that proportion, I'm just going to compare my legs. 15, oh, fun days. 15 over X has to equal 17 over 15. So 225 is equal to 17X. It's okay if it comes out to be a decimal. We just have to round it. 225 over 17 gives me an X of 13.2. You can say units, but you don't have to. Make sure you don't put a fake unit on it. Don't say it's inches if they never told you it is. But if they gave it to you as just a number, you can give it as just a number. You don't have to write units, even though that's the right way of doing it. But whatever, New York State, it's fine. Oh, God. Pluck it and file it. Lovely construction problems. This was one you couldn't have done if you didn't print it out. But Using a compass and straight edge, construct an equilateral triangle inscribed in here. This was one of the very first ones we did. Remember, to be inscribed means it's got to be a triangle where all of its vertices are on the edge. Clearly, it has something to do with this radius, don't it? And hopefully you remember the way we do this is by starting off the same way we would with a regular hexagon. We just have to go around and make a bunch of arcs that are the same size as the radius all the way around. And the last one's going to end up right where A is. And then to make it an equilateral triangle, just connect every other one. About to switch to a pen. Which reminds me, when you take this Regents exam, I shouldn't say when. Yeah, I'll still say when. We're not at the if state yet. But assuming we are still taking a Regents exam in June, when you take it, remember that the whole thing has to be done in pen. There are only 2 times you're allowed to use a pencil: constructions and anything with a graph. If it's not construction or a graph, you have to use a pen. I hate that. I hate it with every fiber of my being, but them's the breaks. So those are the rules. Take 31, toss it. I'm going to give you guys a second if you want to ask me a question in chat, if you want to, ask me how my day is, or ask each other what they want for Christmas, anything. Just take a break. Seltzer is delicious. Seriously, if you're not drinking seltzer, if you're locked in home and you don't have a seltzer, man, you're doing it wrong. Same deal with mandarins. A little bit of citrus always helps. All in all, I thought this was a pretty fair Regents exam last year. The only part of it that had me going, what, is the very last proof. The last proof is, it's evil. But other than that, like I said, it wasn't too bad. I was pretty happy with it. I don't want to throw those away at my desk, so I'll put them in the garbage can later. But oranges. Leave them right there. Okie doke. Part threes. Part threes are fun. They're with 4 credits. Remember, the way your points work is subtractive. If you make a mistake, you lose a point. You don't gain them for doing different things. So always be careful. Always watch for yourself. So Riley is plotting these points to form a quadrilateral. Our task is to prove that that quadrilateral is a trapezoid. They give us this grid on the other side. So I'm going to start off by graphing it. So when you take the exam, it'll be a booklet. These 2 pages are back to back. But Riley is plotting this thing where A is at -1, 6. -1, 1, 2, 3, 4, 5, 6. There's A. B is at 3, 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 8. I could have just gone 2 above A, but I'm lazy. B. C is 6, -1. 1, 2, 3, 4, 5, 6. -1. C. And D is at 1, 0. We need to prove that this thing is a trapezoid. This is a very generous, easy coordinate proof. We didn't do too many coordinate proofs, but we did enough of them to get a good sense of them. Really, all it comes down to is if you want to prove something, 90% of the time, the coordinate proofs they'll give us are going to be quadrilaterals. Sometimes it'll be triangles, but usually it's quads. I want to prove that this thing here is a trapezoid. In order to do that, just like with all these quadrilateral proofs, I need to know what a trapezoid is. A trapezoid is just a quadrilateral with at least 1 pair of parallel sides. At least 1, not exactly 1. So it's super generous. All I have to do is show that two of these sides are parallel. And if I look, it's probably these two. I'm not even going to waste my time with the others. So I just need to show AD is parallel to BC. So that's exactly what I'm going to do. I didn't even need the graph, but I did it to get a good visual sense of what it is I need to do. So like I said, AD and BC. AD and BC are the ones I care about. So I'm going to say AD. And if you remember these coordinate proofs, I always told you should set up a little table where you say, all right, here's my side. Now let me actually do the work for it. The work is I'm going to do the slope. The slope is 0 minus 6 over 1 minus negative 1. So that's going to be negative 6 over 2 for a slope of negative 3. Double check. AD. Does that make sense? Negative 3? Yes. Okay. That little thing there took me, what, half of a second to go, is that a negative 3? Yeah. Do it. It takes no time at all, but it can save you losing your ass on a problem. Please, please, please just do little double checks like that. BC. I know what its slope should be. I can look here and I see what its slope should be. So I know what I should get from B to C, negative 1 minus 8 over 6 minus 3. That is going to be negative 9 over 3, which gives me a slope of negative 3. Prove means you need at least one statement in there. Our concluding statement, our therefore statement. Therefore, since AD and BC have the same slopes, AD is parallel to BC, so ABCD is a trapezoid. Dunzo. There's my proof. Riley is going to define an isosceles trapezoid as a trapezoid that has congruent diagonals. That's a very valid, very standard definition of an isosceles trapezoid. We're going to use that to prove that this thing is not isosceles. So here's what's important about that. An isosceles trapezoid would be one where the non-parallel sides or the legs of it are congruent. Looking at this here, they're not congruent. You cannot use that rule for this proof because they're specifically telling me I need to use Riley's definition. I need to do it by the fact that showing it has congruent diagonals. So I need to take a look at the diagonals, which are AC and BD, and I need to show that they are not the same length. So again, I'm going to set up my little table. I'm going to say, okay, AC. I need to find the length of that. Well, that means I need the distance formula. Well, distance is, I'm just going to take my coordinates again, so I have them here for myself. Boop, boop. From A to C. Difference in my x's squared, 6 minus negative 1 squared, plus the difference in my y's squared, negative 1 minus 6. Oh, let me just double check. I did 6 minus negative 1, negative 1 minus 6. Okay, good. And that's going to be the square root of 6 minus negative 1 would be 7 squared, or 49, plus negative 7 squared, or another 49. 49 plus 49, which would give me radical 98. I'm not going to simplify it. I'm just going to leave it as is for now. Now I'm going to go ahead and do BD. For BD, same deal. If I want the length of it, I'm going to find the distance between those 2 points. Distance formula between B and D is going to be the square root of the difference in the x's, 1 minus 3 squared, plus the difference in the y's squared, 0 minus 8 squared. That's going to give me the square root of 1 minus 3 is going to be negative 2 squared, plus 0 minus 8 would be negative 8 squared. So then that is going to be the square root of 4 plus 64, which is equal to the square root of 68. Now, they're not the same number in the radical, so the radicals aren't the same. You can go through and simplify each if you want to. You don't have to. I can just now go to my therefore statement. Therefore, since AC, the length of AC is not equal to the length of BD, ABCD is not an isosceles trapezoid. Bing, bang, boom, done. Easy. All you had to do for that one was just find the length of those things. Nice sip of seltzer and we're good to go. So sorry if all my pages are now piling on top of each other or getting unsideways for you here. That's the end of 32. Now we've got 33. This one sucks. A child-sized swimming pool can be modeled by a cylinder. So I'm going to go ahead and draw that cylinder. And this is one of those ones where having outside knowledge helps. I know what a kiddie pool looks like, so I have a sense of if I should make it tall, wide, and shallow, things like that. It can be modeled as a cylinder. The pool has a diameter of 6.5 feet. 6.5 feet. And a height of 12 inches. Immediately notice my units are different. They will always try to trick you with that. So what I want to do is I'm going to start looking ahead because it says the pool is filled to 2/3 of its height. Determine and state the volume in the pool to the nearest cubic foot. So I know all of my numbers should be in feet. So immediately I'm changing that to 1 foot. Can you all see this? Is this too small? Hopefully you can see it. Let me know if you can't. So 2 ways to do this. The first way is the smarter way and just say, okay, if it's getting filled to 2/3 of its height, I'm just going to change that to 2/3 of a foot and plug it into your volume formula. I say that's the smarter way because you're doing that conversion or that work at the beginning. The other way is to remember that in the volume formula of a cylinder, height is the linear part. It's not getting squared. So if I'm taking 2/3 of it in the beginning, I could find the volume of the full pool and take 2/3 of that, but I'm going to go ahead and do it at the very beginning. One more place this one's trying to screw you up. You need the radius, and they gave you the diameter. So my radius is 6.5 divided by 2. My volume is going to equal pi times 6.5 over 2 times my height. Really ugly numbers, but calculator likes ugly numbers. It has no problem with them. Since it asks it to the nearest cubic foot, I'm going to leave it in terms of pi. So I will have, I will not leave it in terms of pi. I will multiply by that pi. 3.25 squared times 2/3 gives me a volume of 22.122 something. So my answer, rounded, is going to be 22 cubic feet. Same problem. Remember, this is a part 3 question, which means it's worth 4 points, which means it's being split up by these 2 parts. If this is considered to be part of the same problem, the 4 points is spread over all of them. So if you make mistakes down here, it counts for the whole problem. It's not a separate thing. You don't get 4 points for doing this part right. It's 4 points for everything. Just to keep in mind. A cubic foot equals that many gallons. Determine the number of gallons in the pool. Y'all. 1 cubic foot. 7.48 gallons. 22 cubic feet. Oop, not 7.48. X gallons, just a proportion. Or you can instinctually know that you just have to multiply the two of them together, which is exactly what happens in this when I cross multiply it. 22 times 7.48. Again, I'm using my rounded number because it was my answer for a previous problem. I'm allowed to do that. Gives me a volume, or I'll just say X, is 100, and since they want to the nearest gallon, 165 gallons. I'm just curious, if I used my previous answer, which was my unrounded one, and I multiply that by 7.48, I would have gotten, the same number. The Regents is usually pretty good with that, in the sense of they'll make sure if you use the more precise number, you'll get something that is the same. They're usually pretty good with that. But know that you can use the previous answer here and you'll get the same one of 165 gallons. Oh, this one, I remember this one last year. I think someone drew a picture of Yoda on it for some reason. I'm not really sure why. But I was looking over their shoulder and I saw them drawing a Yoda. And I was like, oh, come, what are you doing? So Nick wants to determine the height, wants to determine the length of one blade of this windmill pictured below. So what we have here is two right triangles that are being formed because I'm eating a clementine, I'm sorry. Using surveyor's tools, Nick is measuring the angle between the ground and the highest point of the top blade, and then the ground to the lowest point. The scary thing about this is the way the diagram is being drawn. Once you pull it out, you're like, oh, that's super easy. The triangle that goes to the very top has an angle of 38.8 degrees. Yeah, this is 440 feet. The other triangle only goes to the center of this wind turbine. Its angle is 30 degrees. Still 440 feet though. If I find the length here, well, that's the same length of this portion. So then I can just subtract it off of this overall to find my X. Doesn't matter which one you're going to start with. I'm just going to make sure whatever I'm labeling things as, I'm going to be consistent with my labeling. So if that's X, that's always going to be X. So in this triangle, I'm going to use a different letter. I'm going to call this part Y. If this part's Y, it's a Y over there as well. So I'm going to start by finding my Y. Trig problem. Opposite, adjacent. So, ka, toa. Opposite over the adjacent. I've got to use tangent. So, tangent of 30 degrees is equal to my opposite side over my adjacent side. So Y is just equal to 440 tangent of 30. You can actually leave it like this and do all your work with it and round it in the end, or I can just say, okay, Y is equal to, again, should still be in degree mode, never leave it, 440 tangent of 30. I get Y is 254.03 something. I'm gonna make sure I'm gonna store that as Y. Store it as Y. Boom, and it's in there. You may jump and go, whoa, that number sounds really, really big. Realize wind turbines can get big. There's no problem with that. If it's 200 feet tall to the center of it, it's a big wind turbine, but they get that big. They grow to be that big. Nature's beautiful. No, but yeah, they could be that big. So then I've got my Y here. Let's just find this overall length, which I will call z. So in that triangle then, opposite, adjacent, again, it's tangent. Tangent of 38.8 degrees is equal to my opposite side, z or z, depending on where you're from, over 440. So then z is going to equal 440 times tangent of 38.8. Realize we expect this number to be larger. 440 times 38.8. And I get that z is 353.769 something. And I'm going to store that in my calculator as z. Alpha z. So if I want x is just equal to z minus y. Z minus y. 99.7349 something to the nearest foot. A 100 feet. Nice and friendly number for that problem. Just 100 feet. Not too bad. Here is that evil proof I told you about that is just so gosh darned evil, but we'll get through it. So again, I'm going to eat a few cells of a clementine, get a drink of seltzer. Just let me know in the chat if you've got any questions, if there's anything you want me to go by. I know there's only 3 of you here, but still. Can you hear my chewing on the feed? Is it gross? And get really close to the mic and just really creep you out, like ASMR videos, but I'm not going to do that. Again, I hope everyone is staying safe, staying smart in this time. You're making sure that you've got things to occupy yourself. The worst thing you can be doing is just getting complacent and lazy. And I mean that you probably notice when summertime hits, you're waking up at like noon and 1 p.m. Meanwhile, in the school year, you're waking up at 5 and 6 a.m. No problem all year. Well, I shouldn't say no problem, but the point is routine and schedule are really what helps keep us healthy. Stress is good. Too much stress is a problem, but stress is the thing that keeps us working and keeps us building and growing. So make sure you have things that are keeping yourself going. That's why our goal for these first 2 weeks we were off was to just focus on review time, to spend time doing exactly this, reviewing problems we've done before. Our goal was not new instruction because at first it didn't seem like we would need to take it that far. Now we'll see as we move forward, we very well may need to shift up our idea. But the point is, regardless of what you're doing, make sure you're doing something. Maybe you're solving a puzzle. Maybe you're playing the new Animal Crossing game. Maybe you are going on Khan Academy and Quizlet and things like that and just training your brain. Make sure you're doing something to keep yourself occupied and keep that brain turning. So let's deal with our nice, evil proof. So, given quadrilateral math, HM is congruent to AT. HT is congruent to AM. This whole thing. They're actually giving us something really important there. And then HE is perpendicular to MEA. And HA is did I say congruent? HE is perpendicular to MEA, and HA is perpendicular to AT. Okay. Prove this. Now remember, when they're asking you to do something like that, proving you've got a product here, really what it's asking you to do is to prove something regarding similarity. Because if you can show that two triangles are similar, you can show their sides are in a proportion, and then you can cross multiply them. And that's what this is. It's a cross multiplication happening. So if I look where TA, HA, HE, and TH, those are all sides between these two triangles. If I can show these two triangles are similar, I can show that their sides are in proportion with one another, and then I can cross multiply. So that is my goal, to show that those two triangles are similar. So I said they actually gave us something really, really cool or important here. First of all, it's a proof. Don't lose a point. Start off with our givens. I'm going to turn the paper just so I can actually write for a second here. I've got my statement column. I've got my reasons. Statements, everything. Quadrilateral MATH with HM being congruent to AT, HT being congruent to AM, HE being perpendicular to MEA, and HA being perpendicular to AT. Reason given. Okay, here's what they actually gave us for free. They only told me that this was a quadrilateral, but I know it's a quadrilateral whose opposite sides are congruent. Because of that, I can say MATH is a parallelogram. And my reason is I can say parallelograms have opposite sides congruent. Or I can even say definition of a parallelogram for that one, but I'm going to be more explicit than that. Parallelograms have opposite sides that are congruent. How does that help me? Well, knowing that this thing is a parallelogram lets me know that these two parts here, boom, boom, are parallel. If they're parallel, that means that this angle and this angle, which are alternate interiors, have to be congruent. So first, let me say that first thing I said. Come on, man. HT is parallel to MA. Definition of a parallelogram. And you know what? While I'm at it, let me say the other two are. TA is parallel to HM. Maybe I'll use it, but it takes nothing to add a correct statement in there. Just throw it in there. Boom. Those are parallel. If they're parallel, angle THA has to be congruent, THA has to be congruent to MAH. My reason is alternate interior angles are congruent. Okay, I've got these. Done. Did I mention anything about these angles yet? No. All I said was that those sides are perpendicular. Remember that any time you have a proof that says two things are perpendicular, you want to explicitly say what you know about those angles. Angle HEA and angle HAT are right angles. That's by the definition of perpendicular. Since they're both right angles, they're both congruent. HEA is congruent to angle HAT. All right angles are congruent, just like the way we've always done these. Anytime you want to say two things are congruent, just make sure you've got a solid stream that lets you get there. Heavy lifting's done. We've got it. So I've got two triangles here. I made a statement about one angle, a statement about another angle. I can say triangle HEA is congruent to triangle HAT. Oh, I just made an incorrect statement. They are not congruent. They are similar by angle. Remember, that's the most used similarity theorem. I am just breaking this lead constantly. All right, do I got another pencil in here? Let's find out. Easy enough. Two triangles, similar by angle. Hey, if they're similar, I know their sides are in proportion. So I'm going to set up this proportion by saying, okay, I know I've got to say something about TA. The ratio of TA to, now they have HA on the same side. So I just want to make sure I'm setting up my proportion in a way that can get me there. And the best way to do that is just by working backwards. Let me divide both sides by HA real quick. That would get me TA is congruent to HE times TH over HA. And then if I look, if HA is here, and that's a leg / hypotenuse, I'm going to say TA is the short leg of one triangle, whereas HE is the short leg of the other triangle. So I'm going to divide it by TH on both sides to get TA over TH is equal to HE over HA. All I'm doing there is I'm just dividing things. The reason I did this is so this is the next statement I'm going to make. TA over TH is equal to HE over HA. My reason is sides of similar triangles are proportional, proportionate, in proportion, however you want to say it. Oh, I'm off camera, aren't I? Sorry about that. And now that I've done that, TA times HA is equal to HE times TH. I guess I could have just said this over that is going to equal this over that, huh? No. That's the thing I want to prove by cross multiplication. Q, E, D, we done. Like I said, that proof was not the friendliest, but once you knew what you were supposed to do, it wasn't too bad. They gave us a lot by allowing us to say that it was a parallelogram right off the bat. So that wraps it up for the June 2019 Regents. The other page is just more work. And then I've got a blank page here for some reason. So for those of you guys who tuned in to watch this thing live, thank you. Hopefully, only had really 2 of you ask questions in the middle of it, but the more I do this, the more often you can engage with me. It's great. It's an awesome way to do that. Remember, we still have the Remind app. Please keep your eyes peeled on that Remind app and also your email in the next few days. You're going to get stuff from me. I'm going to tell you what it is I want you doing. And you can also check my website at ppcsd.org, just so that way you can, any updates I put in email or a remind are either going to be repeated on my website, or those things I send you are just going to be, hey, check out my webpage, and that's where I'll have the announcement, information, and resources for you guys. So thank you. Hope you're staying healthy. You're staying safe. Wash your hands. Keep distant from each other. Drink plenty of seltzer and clementines. Not that they, heal you. It's just, if you heal your soul, you heal your body, you heal your mind. So yeah, have a very wonderful day, everyone. I'll see you soon. And I'll spend probably the next 5 minutes trying to figure out how I end this live stream.